Okay, in 3.6, we are doing higher order derivatives. And first I'm going to show you the notation. So let me make the list. If I do the first derivative, which is what we normally do, and then we'll do the second derivative, third, and then we'll do the nth. Okay, this is just to show notation. Okay, the easy notation, if you have a function that starts with y equals, if I do the derivative once, y prime, if I do the second derivative, meaning I take the derivative of the derivative, it would be y double prime. If I do the third derivative, I'm taking the derivative of the second derivative, so it's y triple prime. If I'm doing the nth derivative, it would just be y n prime. Okay, now what if we are given, actually let me put this in parentheses so it doesn't look like an exponent. Okay, now if I'm given the notation f of x, first derivative f prime of x, second f double prime, f triple prime, and then it could be the fourth derivative depending on what it is. Okay, now the other notation we use for y is we do dy dx. Okay, now what happens if I do the derivative of dy dx? Okay, as an aside, if we normally get dy dx because we're actually doing the derivative of y, and that's how we get dy dx when we're being lazy and we want to write it out. Okay, so now what if I do the derivative of dy dx? Okay, the way we write that for the second derivative, if we're going to say it's d squared y over dx squared. Okay, now say I apply the derivative again, d dx of d squared y dx squared. Okay, now I'm going to have d to the third y over dx cubed. And then if it's the nth, it would be d to the nth y over dx to the nth. And I will space that out better next time I write that. Okay, so let's go ahead and take these higher order derivatives. Okay, so for example, one, it says find the first four derivatives of f of x. Okay, the first derivative we've done quite often. So first derivative, 6x to the fifth, bring down the 4 minus 8x to the third plus 10x minus 3. Okay, now I want to find the second derivative. Okay, so I'm going to take the derivative of f prime of x, and that'll give me f double prime of x. Okay, so I'm going to bring down the 5, 30x to the fourth, minus 24x to the second, plus 10. And you can see it's going down a degree each time. Let's go ahead and do f triple prime of x. So I'm going to take the derivative of f double prime of x. Okay, bring down the 4, 120 x to the third minus 48x. Okay, let's do fourth derivative. Okay, so I'm going to take the derivative of the third derivative to get the fourth derivative. So I bring down the 3, I get 360x to the second minus 48. And so I've taken the first four derivatives of f of x. Okay, let's go ahead and look at example 2. Example 2 says find the second derivative. Okay, starting off, I'm just going to find the first derivative. I'm going to rewrite this. This is x to the 1/2 plus x to the negative 2. Okay, so for the first derivative, I'm going to get 1/2 x to the negative 1/2 minus 2x to the negative 3. Okay, now I'm not going to rewrite it because I'm going to do the derivative again, so I'd rather leave it in the format it's currently in so I can do the power rule again. So now let's do y double prime. So I'm going to take the derivative of this thing. Okay, so if I bring down the negative 1/2, negative 1/2 times 1/2 is negative 1/4. X to the, if I do negative 1/2 and I lower it a degree, negative half 1 minus 1 is negative 3/2. Okay, now let me bring down the negative 3. Negative 3 times negative 2 is positive 6x, and I'm going to lower the degree down to negative 4. Okay, I want the second derivative. Now I am going to rewrite it, and I want to leave it like this. Negative 1 over 4. I have the square root of x to the third plus 6 over x to the fourth. Okay, and that's a decent answer. Okay, let's go ahead and do one more example, but we're going to have to use implicit differentiation. Okay, now I want to take the derivative of this. Actually, I want to take the second derivative of this. But because it's not easy to solve for y, I'm going to have to use implicit differentiation. But because it says second derivative, we're going to have to do this more than once. So let's just start off by finding the first derivative. Okay, this derivative of sine y is, or sine of y is cosine of y. And then because it has a y in it, I'm going to times it by dy dx or by y prime. I'm going to do y prime equals the derivative of x is 1. The derivative of y is 1, but because it has to do with a y, I'm going to do y prime. Okay, let me move the y prime terms to one side. Minus y prime equals 1. I'm going to factor out the y prime. Okay, so I got y prime equals 1 over cosine y to the cosine y minus 1, which is good for the first derivative. Now I want to find the second derivative. Okay, now let me look at this. You know, since I'm going to have to apply the derivative again, I'm actually going to rewrite this. I'm going to write it as cosine y minus 1 to the negative 1 because it's going to be easier for me to use the chain rule on it than if it was written as a fraction. Although I could do it as a fraction. I could do the quotient rule maybe. Okay, let's try it this way. Then I'll think if I want to do it the other way. Okay, now since I set it up like this, I'm using the chain rule. So I'm doing this to the negative 1. So let me bring down the negative 1. And then lower this a degree. Okay, and then I'm going to multiply it by the derivative of the inner function. So the derivative of cosine y is negative sine y times y prime. And the derivative of negative 1 is 0. Okay, let's look at this. Okay, let me rewrite this. Let me see. I'm going to see the negative times the negative is going to cancel. I'm okay with that. Let's move this sine y to the top. The cosine y minus 1 squared to the bottom, and then it has this y prime here. Okay, which I can't leave y prime in my answer for y double prime. However, I already know that y prime is equal to this expression. So I'm going to go ahead and substitute that expression in here. So this is sine of y over cosine y minus 1 squared times, and then for y prime, I'm going to replace it with this expression. Okay, and then just let me rewrite this so it's a little bit nicer. So now I have y double prime is sine of y, and the denominator I have cosine y minus 1 squared times another cosine y minus 1. So that's going to be cosine of y minus 1 to the third power. Okay, I'm going to go ahead and box that. And you know, I think if you had used the quotient rule, it would have been another nice way to do it. We didn't do it that way, but we could have. Okay, let's do one more second derivative with an application. So this says find the second derivative at negative 3, 4. I'm going to use implicit differentiation because it's just too weird to solve for y. Okay, so the derivative of x squared is 2x. Derivative of y squared, 2y times y prime equals 0. Okay, let's solve this. 2y times y prime equals negative 2x. Y prime equals negative 2x over 2y. So y prime equals negative x over y. Okay, let's go ahead and try to get y double prime. Okay, what do I think? I think I'm going to use the quotient rule here. Okay, quotient rule. Let's do low d high minus high d low, square the bottom. Away we go. Okay, let me look at this. Can I simplify it? Not really. Okay, I think that time has come. I'm going to change the y prime into this expression right here, and then see if I can simplify it once it's all in terms of x and y. Plus x, so instead of y prime, I'm going to put times negative x over y. Okay, now I'm going to substitute in a value anyways, so it's not really the end of the world, but I think I'm going to simplify it anyways. I just don't like the y up there. Okay, so that's y double prime, but what did they actually ask me? They asked me to evaluate this at negative 3 comma 4. So the y double prime at negative 3, 4 is going to be negative 4 squared is 16, minus 3 squared is 9, over y to the third is 64. Okay, so at negative 3, 4, the second derivative is negative 25 over 64.